Hello everyone and welcome to a new lecture on Python coding for probability and statistics. In the previous lectures, we learned about Python coding for basic of statistics, then descriptive statistic visualization, set operation, counting, permutation, and combinations. And in this lecture, we want to learn about conditional probability. So we want to calculate the probability of an event given a condition. The probability of an event given the condition refers to the likelihood of the event occurring under the assumption that the specific condition or set of condition is true. For example, we have probability of A equals to 30% and probability of A and B equals to 10%, right? So this is the probability of event A, and PAB is joint probability of A and B. It means intersection of probability A and B. Now, we want to calculate conditional probability. We have probability of A is equal to 30%, probability of AB is equal to 10%, right? Now, we want to define a function like conditional probability, and I will receive probability of A and B and probability of A. Then I will return probability of B given A is equal to probability of A and B divided by probability of A, right? So I can calculate it now. Probability of B given A, I will call this function. Probability of B given A is equal to probability of A and B divided by probability of A, right? So this is probability of B given A. And if I want to remove the number of decimal points, simply I can say conditional probability. So I can say probability of B given A is equal to then this one, and in here I will add this one, and also I need to add this one, and in here I also say it should be 2, right? So probability of B given A is 33%, right? It means if we know that this A already happened, what is the probability of B given A is equal to 33%. Next, I want to check if two events are independent. As I defined in the lecture, two events are independent if the occurrence of one event does not affect the probability of the occurrence of the other event. For example, we have probability of A equals 40% and probability of B equals 50%, right? And also I have probability of A and B equals to 20%, right? Then I will define P of A equals to 0.4, P of B equals to 0.5, and PAB equals to 0.2, right? Then I can check whether these are independent or not. So I can say, for example, print if are A and B independent, right? Then here I can say if PAB equals to PA multiply PB, right? So it's true, right? Because PAB equals to PA multiply PB. I want to check joint probability. Joint probability is the probability of two or more events occurring at the same time or in combination. So I can say if PA and B is equal to 0.3, right? And if PB is equal to 0.6, then I will print if PA given B equals to PAB divided by PB, right? 0.5. So it is simply probability of A given B is equal to probability of A and B divided by probability of B. Then the next concept is Bayes theorem. As I already explained in the lecture, Bayes theorem describes how to update the probability of a hypothesis based on new evidence, combining prior probability with the likelihood of the observed data. For example, I have a probability of B given A equals to zero point 0.8. Probability of P given A is 0.8. Probability of A equals to 0.3, and probability of B equals to 0.5. Then I want to calculate probability of A given B. How to calculate probability of A given B based on this information that I have. Again, I can say that I will change this one. So probability of B given A is equal to 0.8. Probability of point, I can say point given A is equal to 0.8, and probability of A is 0.3, and probability of B is 0.5. Then what is the probability of A given B? So probability of A given B is equal to probability of B given A multiply probability of A divided by probability of B. Bayes theorem says probability of A given B is equal to probability of B given A multiply probability of A divided by probability of B. In this way, I can print it, right? Print if A given B is probability of A given B, and probability of B given A, and in here I can say 0.2f, right? So it is 48%. The next topic is total probability law. The law of total probability states that the probability of an event can be found by considering all possible ways the event can occur, weighted by the probability of each condition that might lead to it. For example, I have probability of A given B1 is equal to 0.7. Probability of A given B2 is equal to 0.4. Probability of B1 equals to 0.6, and probability of B2 equals 0.4. Then probability of A equals to probability of A is equal to probability of A given B1 multiply probability of B1 plus probability of A given B2 multiply probability of B2. Very easy, right? So probability of A given B1 multiply probability of B1 plus probability of A given B2 multiply probability of B2, right? And then in this way, I can print the probability of A, which is 58%. Next, I want to simulate conditional probability with random sampling. It means the probability of an event occurring given that a sample is drawn from a population under specific conditions or constraints. For example, I want to simulate probability of A given B, where A is a number greater than 5 and B is an even number from 1 to 10. So for this one, first I need to import random. Then I can say numbers equal to list of range 1 to 11, because I want to go for list of numbers from 1 to 10. Then I can say trials equals to, I want to simulate for 10,000 times, right? Then I can say B count is equal to 0. We want to count of the items B occur. Then A and B count, so I can say AB count equals to 0. This one, count of items A and B occur. It means even number greater than 5. The previous one is the B. This is the even numbers, events, right? Now I can say for underscore in range, trials. So in here, I use for underscore in range. This is often used as a placeholder for a variable when the value is not going to be used. So then I can say, for example, here, I can say num is equal to random. We imported random here because of this one, right? Because we want to randomly pick a number. Randomly choice and out of where? Out of numbers. Then if we want to check if number is even, our event B, right? If num mod 2 equals to 0, right? It means it's even number. Then B count will be plus equal to 1 because we want to increment B counter because 1 has been added, because one even number has been found. Then if num is greater than 5, we want to check whether event A happened or not, number greater than 5. Then we say AB count plus equal to 1. We will increment A and B counter. That's all. Then I can say probability of A given B is equal to AB count divided by B count, right? AB count divided by B count, and then we print F probability of, can say I here simulated probability of A given B is this one, right? So let's try, and it shows 60%. Probability of A given B is 60%. Then we go for Bayes theorem with multiple conditions. The probability of an event occurring giving several condition factors by updating prior beliefs based on new evidence and their respective likelihood. For example, we have like probability of, for example, probability of B given A1 is equal to 0.9. Probability of B given B given A2 equals to 0.6. Probability of A1 equals 0.4, and probability of A2 equals to 0.6. Now we want to find out probability of D using total probability law. So in here, we say probability of B equals to probability of B given A1 multiply probability of A1 plus probability of B given A2 multiply probability of A2. Next, we go for probability of A1 given B, which is equal to probability of B given A1 multiply probability of A1 divided by probability of B, and then we print it, right? We print probability of A1 given B. So it is 50%. Next, I want to go for conditional probability using a dictionary. You know, dictionary is a data structure where we have keys and values. So for example, we have joint probabilities as a dictionary. So in a dictionary, we have this information. For example, we have like 4 cases, 4 keys and values. I will do like this. And okay, first one is probability of A and B, right? Let me copy this one for easy typing. So probability of A and B is equal to 0.2, 20%. Probability of A not B. A not B is 0.1, 10%. Probability not A and B is equal to 30%. And probability of not A and not B. Not A and not B is equal to 40%, right? So this is our dictionary. Now, probability of B is equal to joint probabilities, and in here I can say A and B, A and B plus joint probabilities, not A, not A and B. Not A and B. In here, I simply say probability of B is equal to probability of A and B plus probability of not A and B. Then probability of A and B, is equal to joint probabilities. Then in here, I can say for this one, A and B, probability of A and B, and probability of A given B is equal to probability of A and B divided by probability of B. Then I can print, fs3, fs3 probability of A given B is equal to probability of A given B, right? So this is 40%. We tried conditional probability with a dictionary structure. We have a joint probability table here. Then we calculated the probability of A given B. We can also do using lists. For example, we have two lists of outcomes and we want to calculate probability of A given B, where A is a value like 3 and B is value like 0. So I can say outcomes equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is sample space. Then B outcome is equal to, for example, I can say X for X in outcomes if X mod 2 is 0. It means it's an even number, right? Then in here, I can say AB outcome even A and B. It means odd and greater than 3, right? AB outcome is equal to X for X in B outcome if X greater than 3, right? Then probability of A given B is equal to length of A and B outcome, AB outcome, divided by total length of B outcome, right? Outcome. So then I can print it, which is 0.8. What I calculated here, in here I say mod 2 is equal to 0. It means for even numbers, right? It's 0.8, 80%. But if I want odd numbers, I should change this one, which is 60%. Next, I want to go for Monte Carlo simulation for Bayes theorems. We want to use random sampling to approximate the posterior distribution by simulating numerous possible outcomes based on prior probabilities and likelihood. For example, I want to simulate probability of A given D, where A is rain like 30%, D is clouds, and probability of D given A is 90%, and probability of D given not A is 40%. So I want to just simulate it. So I can say trials is equal to like 10,000. Probability of A is equal to 0.3 and probability of D given A is equal to 0.9. 0.9, it means, so 0.3, it means probability of rainy, and probability of D given A is cloudy, right? Probability of D given A, when we say probability D is cloud, probability of D given A, it means clouds given rain, right? Then probability of D given not A, it means cloud given no rain, right? There is no rain because of this cloud, is 0.4. Then D count is equal to 0. This is the count for clouds. And AD count is equal to, AD count is 0 because we want to count of rain and clouds. So here, for underscore in range of trials. So for underscore in range of trials, in here we say that is rain, right? We want to simulate rain true if random is less than 3. So we can say is rain equals random dot random. We randomly generate a number if it is less than the probability of A. Okay. Then if is rain, it means is this condition is okay. Then is cloudy is equal to random less than probability of D given A. Otherwise is cloudy equal to random P D given not A. It means we want to simulate clouds given no rain. Then if is cloudy, then we increment clouds counter, right? So D underscore count plus equal to 1. And if is rain, then A and D count will be incremented by 1, right? Then we can say probability of A given D is equal to A D count divided by D count, and then we print it. So there is one problem here, and the problem here is this one, right? Less than. So it is 51%. Maybe the answer you get is a little bit different. Okay, let me explain again what happened here. First of all, we say we want to simulate, we want to go for this random selection 10,000 times. Then we want to select the probability of A given D. It means probability of rain given clouds, right? So we have a trial here 10,000. Probability of A is probability of rain, and probability of D given A here is rain because of the cloud is 90%, right? For each trial, it means 10,000. The code simulate whether the rain is rain based on the probability of this 30%. If it rains, it simulates the likelihood of clouds based on probability of D given A. Probability of D given A. If it doesn't rain, it simulates the likelihood of clouds based on probability of D given not A. If clouds are present, it means if is cloudy is true, it updates two counters, D count and AD count if rainy. So it calculates probability of A given D is equal to probability of A and D intersection divided by probability of D. This code in general estimates how likely it is that it rained given that clouds are observed by running a simulation based on some specific probabilities that we have here. Okay, so that's all in this lecture. We tried conditional probability. We try to do some basic calculation of probability of an event given a condition. Then we check if two events are independent. Then we calculated Bayes theorem. We calculated total probability law. We simulate conditional probability with random sampling. And also we did Bayesian theorem with multiple conditions. We did conditional probability with the dictionary. We did conditional probability with list. And finally, we did Monte Carlo simulation for Bayes theorem. So I hope you understood in general. Please practice and feel free to ask me questions by leaving a comments below this video. Thank you for your attention and see you in the next lecture.